this lesson is lesson 87, arc length. Now, we've done a lot with circles. We've done area, we've done circumference, we've done the measure of arcs by their degrees. I'll kind of refresh you on that here just a second. Okay, we've got a circle, estimating the center. We've got the radius. So if I want to find the circumference of this circle, we know, I'll write that out. Is pi times the diameter. So if you know the radius, then you can find the diameter, and it's simply pi times the diameter. Now, if I have an angle in my circle, if I have an angle of, say, well, I'll tell you what, let's go ahead and make this circle 17 centimeters radius, and let's go ahead and find its circumference, and then I'll address what I was talking about. So we're going to do pi times, if 17 is the radius, then 34 would be the diameter, and 34 times pi is approximately, we're going to round here to, I believe, 2 decimal places. You'll just have to watch when you do the multiple choice on your lesson. And this is about 106.81 centimeters. Now remember, circumference is the distance around the whole circle. Now, what if I have an angle? Let's take this, and I'm just eyeballing it. I don't have a protractor. But I'm going to say that this angle is about 60 degrees. Now, we know from central angles that if the angle is 60 degrees, then the arc is a 60-degree arc. But we're interested in just knowing, we want to know literally if the distance around this whole circle is about 107 centimeters. Then I want to know what would just be this piece of the crust. Cut it off, straighten it out, and how many centimeters would that be? Well, it's going to be a part of the circle, and we've got to decide what part of it's going to be. If the distance from here all the way around is 106.81 centimeters, then this has to be a piece of that. And to find that, if you think about it, and we'll call this problem number 1, I'm going to call it arc length for AL. And what we're going to do is take the circumference, which I'll go ahead and put the pi times 3/4, but we're going to multiply by the fraction of the part we want. Well, we know the whole circle is 360 degrees. And we only want the part that is 60 degrees. And so we're actually doing, if you reduce that, that's 1/6. We're actually doing 1/6 of the whole circumference is what we want, and that will give us just this length. And I usually cancel before I do the multiplication. That's just what I'm used to doing. I think your classwork, I think it will just give you the decimal. I don't think it's going to give you, but I'm going to do both just for you to kind of see what's going on. I'm going to go ahead and cancel these. 60 goes 1 time and 6 times. And I end up with, this is over 1. And so I end up with 34 pi over 6 times 1 times 1, which actually that will still reduce because I can divide by 2. But I'm just mainly, and we've had that discussion about what is the exact answer. And sometimes in a college level class, they would want to know what's the exact length of that arc. Well, we're probably more interested in it by the decimal because that makes a little bit more sense to us as we divide it out. And so if you divide, either multiply here and divide, or if you do it in either one of these formats, you'll get about 17.80 centimeters because you're actually finding a 1/6. See, 60 degrees is a 1/6 of the circle of this. So if you divide 6 into that, that's what you end up getting. Okay, number 2. Before I do that, let me give you pretty much what we're doing. The arc length, and the next lesson will be area. We'll do the same thing with area. We know how to find the area of the whole circle, but we're going to only find the area of like the piece of pie or the pizza, just that, and that's called a sector. So the arc length is equal to the, let's see, I think I'll put degree of angle, which in this case was 60 degrees, over 360. Now, why do we use 360? Because that's how many degrees are around the whole circle. And then times your pi times your d. So you're taking a part of the circumference. So number 2. Let's do, and I think, I was thinking that your problems might have some with diameter. I think they're all radius, but I'm going to go ahead and do a diameter problem just for the sake of, I mean, whether you're given the radius or diameter, you should be able to find the other. If you're given the diameter, you know how to find the radius, or vice versa. So this time I'm going to set the diameter to 24 inches. And I'm going to set my angle at, if this is 90, I'm going to set it about, and we know this is 180, I'm going to set it at 120 degrees. So this is my arc length from here to here. Okay, and I want to know the length of that arc in inches. So arc length is equal to the degree of your angle over the degree of the whole circle, times pi times the diameter, which is the 24. So when we get ready to multiply those, you want to do some canceling. I like canceling. 120 will go 1 time and 3 times, and I recognize that the 3 and the 24 will cancel. It's just always good, especially if you're going to be leaving it, if you're not going to be doing it as a decimal. So we've got 1 times 8 times pi on top, over 1 times 1 times 1. So it's 8 pi, exactly 8 pi inches. Start to put centimeters like the last one. And then the decimal, if I take 8 and multiply by a pi, and you could multiply at any point, it will give you the same answer. These are equal, they're just one's reduced. And that is 25.13 inches. Now remember, if your calculator doesn't have a pi key, you need to use approximately 3.14159. That's going to be more accurate with your multiple choice than just 3.14. Okay, let's do one more because you're going to have kind of an interesting setup in some of them. In my last example, we've never had an angle, I don't think, an angle more than 180 degrees, but we know there's 360 in a circle, so we know there are angles that go more than 180 degrees. And we're going to let the radius be 9 millimeters. And we're going to use a 200 degree angle. Well, if 180 is here, 200 is going to be somewhere in this vicinity. And they'll usually put like a little spiral on it. They'll put a little arrow to show you where they're talking about. And we're going to use 200 degrees. So it's over half. So in this case, if you think about it, remember we had major arcs and minor arcs. So in this case, you're finding the length of the major arc, you know, the biggest one, and then this one is the minor arc. So the arc length is equal to the angle 200 over the number in the circle times pi times the diameter, which would be 18. Then if you want to do some canceling, or if you want to just multiply it like it is. Actually, I think on this one, I just multiplied like it was. I just took, I think I actually have it right here worked out. I took 200, I'm not sure why it's done twice, so I'm going to type it again. I did 200 times pi times 18 divided by 360. So you don't even have to reduce it before. And I got about 31 point, we'll do 2 decimal places, 42. And this is millimeters.